Class 9 Subject Physics. Topic Mathematical form of second law of motion. To derive this expression for the mathematical form of second law, first we need to consider. What consider? Let us consider m to be the mass of the body. U be its initial velocity. V its final velocity. T is the time taken for motion. So in this case the object is moving in a straight line, as you see. This is the simple diagram to show the motion. We know that at this time we considered the time to be 0, and at this time position it is considered to be t. Now we know that when it comes to initial velocity, the object started moving when t is equal to 0. U be its initial velocity, and when it reached to this point, its velocity become v. Whereas we have to calculate the momentum, change in momentum. So the initial momentum is represented by P1, which is mass times initial velocity. Similarly, for final momentum, that is P2, which is mass times final velocity. Now we need to find the change in momentum. So change in momentum is final momentum, that is P2, minus initial momentum, that is P1. When we going to substitute the value, we will get mv minus mu, where m is taken as common and it will be v minus u. Now we need to find what is the rate of change of momentum. So in rate of change of momentum, we will get the time in denominator. So it will be mv minus u upon t. Now we know that according to second law, the applied force is directly proportional to the mv minus u upon t, and we know that F is represented by capital F is equal to, in place of proportional we introduce a constant, that is k, mv minus u upon t. And we know that we have learned the formula from the equation of motion that v minus u upon t is the value of acceleration. So we are going to substitute this value in the above equation, and we get F is equal to k m a, and we assumed the k to be 1, so k will be 1. So F is equal to m a is the mathematical form of second law of motion, where SI unit of F, which is force, is Newton, which can be further expressed as 1 Newton is equal to 1 kg into 1 meter per second square. So this is how we define newtons. 1 Newton is equal to 1 kg into 1 meter per second square.